All right, today we're going to move into trapezoids and kites. And this is going to stay in the quadrilateral family, but we're going to move outside of the parallelogram family. All right, so in the parallelogram family, we followed a series of properties that held for each of the other three main shapes we talked about, which was a rectangle, a rhombus, and a square. All right, so when we step out into trapezoid, all right, trapezoid is no longer under the same umbrella as a parallelogram, all right? Because the definition of a trapezoid, all right, a quadrilateral is a trapezoid if and only if it has at least one pair of opposite sides parallel. All right, so in this picture, if AB and DC are parallel to each other, all right, then that picture would be a trapezoid because we have the one pair of parallel sides and then the other two are or aren't parallel. All right, now I've seen definitions as well where instead of saying at least here, they say exactly. All right, so exactly one pair. And what this does is that would totally separate the trapezoids so that there's no overlap between trapezoids and parallelograms. There's been a variety of definitions that have been chosen for that. I've seen both. And I'm really comfortable actually with just using the exactly. It saves some confusion with that overlap between the two shapes. All right, now some vocabulary that goes along with this is we have bases. All right, the bases are always the parallel sides. So we're going to have base down here at the bottom, and we're going to have a base up here at the top. All right, usually we just say base 1, base 2. All right, the legs. All right, the legs are the non-parallel sides. So we have legs on that side and legs for this side. All right, those are the legs. The base angles are what forms an angle between the legs and one of the bases. All right, so when I look at this angle over here, all right, and this angle over here, which is a different size, all right, those are considered base angles. All right. Now, they are not congruent necessarily, but they are called base angles. I know we had in isosceles, we had base angles and they were congruent, right? But in general on these, they're not necessarily congruent. We also have base angles that are at the top as well, so A and B would also be considered a base angle. All right, then one more feature that we talk about quite a bit is the mid-segment. All right, and the mid-segment is the segment that joins the midpoints of each side. So in this picture, this line here from N to M, all right, is the mid-segment. All right, because it joins those two sides. All right, now when I go down to example one, it's identify each of the following and use the diagram. All right, so first one it says is bases. All right, so when I look at that base, we've got AB is a base, all right, and DC is a base. All right, then it asks for legs. Legs are AD and BC. All right, base angles. All right, for base DC, that would be angle D and angle C. And then the base angles for AB at the top would be angle A and angle B. All right, and then our mid-segment on that is NM. All right, and that would give us all of those features. All right, now another definition that we're going to come into is an isosceles trapezoid. All right, so an isosceles trapezoid, all right, is a trapezoid where the legs are congruent. All right, so in this picture we have AD parallel to CB, all right, and then we have CD is congruent to BA. All right, so in that case, this is considered an isosceles trapezoid. All right, now in an isosceles trapezoid, we get a couple of associated theorems. All right, the first one says that the base angles would be congruent. So what I can mark is I can go ahead and say angle C and angle B are congruent, and in turn, angle D and angle A are congruent. All right, because if it's an isosceles trapezoid, then we have congruent base angles. All right, the next theorem says if a trapezoid has one pair of congruent base angles, then it's isosceles. All right, so that forces your hand, all right, it's really the converse, all right, kind of the first one, all right, because it takes us back in the other direction. So if we know it's an isosceles trapezoid, we get congruent base angles, but if we have congruent base angles, then we're going to know it's an isosceles trapezoid. All right, the next theorem says that a trapezoid is isosceles if and only if its diagonals are congruent. All right, so if I draw in this diagonal, all right, and I draw in this diagonal, all right, we know that those two are congruent. All right, so we'll go ahead and just mark them both with 2 tick marks, and that's to represent the entire diagonal, not just the bottom sections of it. All right, and then the last one says the mid-segment of a trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. All right, so this one, notice it doesn't talk about isosceles. So this one is in effect for all. All right, and really what it says is if I have a trapezoid, any trapezoid, all right, doesn't have to be isosceles. All right, if I know this base is 3 and this one's 7, the mid segment is going to be basically half the sum of the two bases. So 7 plus 3 divided by 2, all right, which equals 5 in this case, and that's going to be my length for the mid segment. All right, now notice that from 3 to 5 is 2 and 5 to 7 is 2. So sometimes you can use that number pattern to find a missing side pretty easily. All right, so those are the theorems that are in play. What we're going to do is we're going to move into some problems where we use this. So we're going to do the first 2 in this video, then I'm going to take a little break, and we'll do the last group in the next video. All right, so in number 1 it says CF is the mid-segment of trapezoid ABE. All right, so right there I know that FC equals the sum of the bases, 14 plus 6, divided by 2. All right, 20 divided by 2 is 10. All right, so FC or CF is 10. That piece is done. All right, the next thing that I know, all right, is that because of parallel lines, these two, the consecutive interior angles, have to be supplemental. So I have 6x plus 3x equals 180, and that's going to be 9x equals 180, or x equals 20. All right, so we get our x value. All right, and then we can do the same thing on the other side with b and d. So if I take 4y plus 24 plus 5y minus 6 and set it equal to 180, I'm going to get 9y plus 18 equals 180. All right, I'm going to choose to make my life a little easier. I'm going to actually divide everything by 9 right here. So y plus 2 equals 20. And then y equals 18 when I subtract that over. All right, so we get 18 for that piece. And again, we're using on this one, we're using consecutive interior angles, our supplementary, a property back from parallel lines. And we get to use that because we know the top and bottom lines are parallel. All right, so now if I go to number 2, all right, in number 2 it says OL is the midsegment of isosceles trapezoid JKMN. All right, find x and y. All right, so they said isosceles, so that tells me these two angles are congruent. All right, so I'm going to say 45 equals y minus 5, so y is going to equal 50. All right, and that's my first piece of this. Now, the next thing it asks for, we've got an OL in there, so I know that that's going to be the average of the two bases, or half the sum. So 27 plus 9 divided by 2. All right, so 27 plus 9 is 36, divided by 2 is 18. All right, so OL has to be 18 in this one. All right, now we're looking for x, and x, you've really got two choices. I'm going to actually lean on this side, personally, because I know those two have to be supplementary. So I'm going to take 11x plus 3 plus 45 equals 180. All right, that's 11x plus 48, equals 180. All right, if I subtract 48 from both sides, all right, that gives me a 132 equals 11x. If I divide by 11, that gives me 12. All right, because 11 times 12, we can always go off to the side for not positive and do that real quick. So there, we got that, carry the 0, drop the 0 in, then we've got a 2 and a 1. So that's going to give me 132. All right, so that does check. All right, so we get our x value is 12. All right, so that takes us through the first two. I hope that's kind of clear how we're using those theorems on the first page to help us answer some questions about trapezoids. All right, I'll be back in the next video.